Next few methods of preparation of alkanes are decarboxylation and coal-based electrolysis. So decarboxylation happens in the presence of soda lime. Soda lime is a mixture of NaOH and calcium oxide in 3:1 mixture. Alright, 3:1 ratio. If you take NaOH plus calcium oxide, it is known as soda lime. So in presence of soda lime, if you take a carboxylic acid salt, let's say if I take CH3COONA, decarboxylation in short means removal of carbon dioxide. If you take carboxylic acid salt CONA in the presence of soda lime, that is NaOH plus calcium oxide, then reaction happens in such a way that this CaCOONA part is removed. So it is removed in the form of Na2CO3, and this H combines with this methyl to give us methane. Alright, so Na2CO3 is removed and you get methane. In short, if I tell you, if you have RCOONA, then in the carboxylation and you see these reagents, then just remove this part and join H to this R and you get the alkane required. Alright. So removal of carbon dioxide is known as decarboxylation. So in both of these examples you can check out, we have taken a carboxylic acid here for 2 carbons and you get alkane of 1 carbon. Here also you can see 1 carbon is getting removed. So always remember, in decarboxylation the reactant has 6 carbons, then in alkane formed or the product formed 5 carbons will be there. So there is decrease of 1 carbon from the reactant in the formation of product. If you have to form, let's say, pentane, then you have to take 6 carbon carboxylic acid salt, that means sodium hexanoate will form pentane. If you have to form ethane, you have to take sodium propanoate. You have to increase 1 carbon in the reactant to form a given alkane, because there is decrease of 1 carbon during this formation. Next is coal-based electrolysis. Coal-based electrolysis occurs in the presence of carboxylic acid salts, and the number of carboxylic acid salts taken in this reaction is 2 moles. You have to take 2 moles of carboxylic acid salts and do the reaction. For example, if I take CH3CONA, we have to take 2 moles of CH3CONA and electrolysis happens for this salt. Then what will happen? You get 2 moles of sodium acetate and the ionization will happen for that, and you get acetate ions 2 in number. Then at anode, there is a positive terminal. Here acetate comes and reaction something like this happens. Loss of 2 electrons happens and you get 2 acetate free radicals. Alright, there is loss of 2 electrons, 1 electron from each acetate ion. Oxidation occurs over here. Now you have 2 CH3CO group. Here oxygen has free radical. Now this bond is broken like this, so that you get free radical. One free radical is generated here and one free radical is generated here. So see, one free radical here, one free radical on this carbon, free radical form a pi bond. So this molecule gives us CO2. So you get CO2, 2 moles of CO2 are formed, plus 2 methyl free radicals. See, 2 methyl free radicals are also formed. So these methyl free radicals combine with each other to give us ethane. Alright, so at anode you get carbon dioxide and ethane. At anode you get carbon dioxide and ethane. At cathode what happens is 2H plus gains 2 electrons and you get hydrogen gas at cathode, which is liberated back. So this is what happens in coal-based electrolysis. As you can see over here, free radical is formed. So the mechanism is free radical mechanism during coal-based electrolysis. So what happened at anode? At anode you get alkane plus carbon dioxide. At cathode you get hydrogen gas, and the medium finally is basic in nature because the final solution contains NaOH. So final solution during coal-based electrolysis is basic in nature. So pH is greater than 7. Anode, alkane plus CO2, cathode, hydrogen gas, and final solution is basic. Can we prepare methane through this method? I think your answer will be no. We cannot prepare methane by coal-based electrolysis because you have to take 2 moles, alright. So if you take 2 moles, then the number of carbons at least will be 2. So ethane is the alkane we can form through this method. Methane is very difficult to form through this method because coal-based electrolysis at least 2 moles have to be taken. Alright. So the basic mechanism is, if I tell you which alkane will be formed through coal-based electrolysis, what you can do is just remove this carboxylic group. Remove this carboxylic group. What you will get is 2 methyl groups you will get. 2 methyl will combine with each other and you can easily get ethane molecule. You can easily get ethane. So answer you can get. What you have to do? Remove carboxylic group from the carboxylic acid salt, and the carbon groups you get, you combine them together and you can get the alkane which is produced from the given carboxylic acid salt. So this is it for now. Thank you.